In this video, we're going to talk about reflection transformations. So first, let's get started by just graphing these three graphs, f of x, these three functions, f of x, g of x, and h of x. So I already have in the table f of x for specific values of x. Notice when you plug in a negative value for x, there's no answer. The answer doesn't exist. So DNE stands for does not exist. Okay, now let's do the same thing. So for g of x. So if I plug in negative, first let's say what this is. So negative f of x, that'd be negative f of x equals the square root of x. So I just plug that in, negative square root of x. Then h of x is f of negative x. So that means where I see x in f, I have to put in negative x. Okay, so alright, so now let's go ahead and plug in the different values. So let's start with negative 4. So for g, negative square root of negative 4, that does not exist because you can't take square root of a negative number. Same thing when you plug in negative 1. Then if you plug in 0, square root of 0 is 0. Then negative square root of 1 is negative 1. Negative square root of 4 is negative 2. So now let's do h of x. When you plug in negative 4 for x, if you plug in negative 4 for x, you get negative, negative 4. So that cancels and that makes positive 4. Square root of positive 4 is 2. So 2, same thing for negative 1. You get 1, then 0. And then when you plug in 1, you get square root of negative 1, which does not exist. Okay, and same thing for 4. So let's go ahead and plot these guys. So let's start with f of x. This is what f of x looks like. Okay, and now let me label that f of x. And now let's do g of x. So it starts at 0, and then it goes 1 when x is 1, y is negative 1, and then when x is 4, y is negative 2. So that's g of x. Alright, so there you see, g of x is a reflection of f of x across the x-axis. So this is a reflection of f of x about the x-axis. Okay, and if you had a point in f, the way you would get the corresponding g, so for example, the point 1, 1 here now is 1, negative 1. So what did you do? You basically changed from the positive y to a negative y. So to reflect about the x-axis, you change the y-coordinate sign. So from being positive to negative. Alright, so now let's do h of x. So when x is negative 4, h of x is 2. When x is negative 1, h of x is 1, then 0, 0. Okay, so it looks like this. So this is h of x. Okay, so h of x is a reflection of f of x over the y-axis. Okay, so this is a reflection of f of x about the y-axis. And if you had a point f of x, so say that 1, 1, 1, and then you wanted to get what it is in h of x, oops, I wrote that point wrong. So it'd be negative 1, and then this one is 1. So that's what this point here is. So see what you do is you change the sign. You change the sign of the x-coordinate. So to reflect about the y-axis, you change the sign of the x-coordinate. To reflect about the x-axis, you change the sign of the y-coordinate. Okay, so when you have negative f of x, that's a reflection about the x-axis, and then f of negative x, it's a reflection about the y-axis. The next slide from this up, and we'll do a few more examples. Okay, so this is the rule I just said. So negative f of x is a reflection about the x-axis. You change the sign of the y. F of negative x is a reflection about the y-axis. You change the sign of the x. Okay, so now let's do these two examples. So what's g of x? G of x is basically the same thing as negative f of x. Okay, so that is the reflection about the x-axis. So reflect f of x about the x-axis, right? So you know what the graph of f of x looks like. You know, the absolute value sign looks like this. Okay, so if I wanted to graph g of x, I would reflect that about the x-axis, and it would look like this. So this is g of x, and this is f of x. Okay, so now let's do the second example here. This one is not just single reflection transformation anymore. This is a reflection, but then it also has this +2. So this is more than one transformation. Okay, in the previous video we talked about vertical and horizontal transformations. So this is one of those. Let's figure it out. Okay, so this is the same thing as f of negative x plus 2, right? If you were to plug in negative x plus 2, you would get g of x. All right, I'm going to rewrite this as f. I'm going to pull out that negative sign, so I'll get x minus 2. So I want to get the x by itself. And you should always do that when you're writing your transformations. So, so now we have f of negative x minus 2. So now we have this negative, and then, so this negative here. It's inside what the, inside these parentheses. So it's this sort of transformation. Reflection about the y-axis. So that's the first thing I'm going to say. Reflect f of x about the y-axis. So that's the first thing I'm going to say. The next thing I'm going to say is I see that minus 2, okay? And I'm saying, I know that, when it's inside of the parentheses, then it's a horizontal transformation. And then when it's negative like this, I know that it's a horizontal transformation to the right. So now I know, okay, I'm going to, horizontal shift to the right by 2. Okay, so now if I were to draw this, I'm going to draw it up here because I've run out of room down there. So this is what f of x looks like. I should go down. It should go all the way down to this 0, 0, okay? That's what f of x looks like. So now what does g of x look like? Well, I know that I'm going to need to flip it, so I'm going to draw this, just dot it. I know I'm going to need to flip it about the y-axis. Oh, well, I drew that wrong, because about the y-axis would be, flipping it this way, right? This is the y-axis. So if I were to flip it about the y-axis, I'd be flipping it this way. And, parabola is symmetric, so if I flipped it, it just lines up right on itself again. So it's okay. And then a horizontal shift to the right by 2. So right by 2, so 1, 2, so over here. Here's 0, 1, 2. And so my parabola will look exactly the same, except it'll be to the right by 2. Okay, and this is what the function g of x would look like.